Hello everyone, I am Professor Girish Kulkarni, working as Assistant Professor in NK Orchid College of Engineering and Technology, Solapur. In last couple of weeks, I had prepared two videos as a part of this international FDP on environment and sustainability. And in both videos, I had discussed about the parameters of green construction technologies. This is one more video I'm preparing for same FDP with some additional content like different ISOs which are used in the view of green construction technologies and environment sustainability, and also with some computations and examples and case studies for green construction technologies like installation of solar energies and so. So this slide will tell you about the videos that I have prepared in week 1 and week 2, showing the YouTube links for the same videos and some credentials. If we discuss about the outcomes of all these three videos, students will apply simple techniques in building planning and town planning to meet up sustainability criteria. Students will design various project elements by applying suitable design principles to meet up sustainability criteria by saving materials and so on. Will design and commission the rainwater harvesting system for residential building that will reduce the electrical demand and freshwater demand, leading to sustainability. They will be motivated to commission a solar power plant and study the reduction in CO2 emission. And the basic objective of all this workshop, that is how we can meet PO7 of engineering curriculum, that is program outcome number 7 regarding environment and sustainability in development projects. So student will apply this particular PO of a program, engineering program, in various engineering development projects. Just to revise, I had listed these principles of green construction technologies and how we can reduce the carbon footprints in construction industries. These were site planning, design and material, energy, water management, and waste management. So details about these I have discussed in earlier two videos, so I will not be repeating those again. So here you can see there are different ISOs certification numbers, identification numbers are there for ISOs, showing the title, that is the purpose for which this particular ISO certification is used, and the reference from which I have taken these particular ISO numbers. For example, you can see ISO 1931 is there, that is related to sustainability in building and civil engineering works, framework for methods of assessment of the environmental, social, and economic performance of a construction work as a basis for sustainability assessment part 2. Likewise, I have listed various ISOs which are required in the view of environment and sustainability. Likewise, one more is there, ISO/TC 180, that is related to solar energy. There are a few more. ISO 14001 is the very major, what you can say, ISO related to environmental management systems, encompassing various parameters which are related or pertaining to environment and construction projects. Here, it is shown, or it is explained how the carbon footprints or emissions, CO2 emissions, are calculated. Examples, couple of examples I have taken here. Electricity. When we are using electricity, CO2 is emitted because of the generation of electricity in the conventional power plants. When we are using the conventional energy sources like thermal power plant is there or something, right? So CO2 emission is liable to happen. So it is explained how to calculate CO2 emission here in kgs, right? So some basis of average amount of electric bill per month divided by price. So how much electricity unit we are using, and then electricity emission factor is taken considered, and per year it is calculated. So reference I have mentioned here from where I have taken this formula. Likewise, if we are using some vehicles for transportation of material or transportation of water, where water is a costly commodity in water scarce region, it is transported by using some vehicles even. So if we are using vehicle for different purposes, as I said, transportation of water, transportation of construction material, and so on, CO2 emissions can be calculated for those vehicles as well. So formulas are written here. Again, I have taken this from same website as a reference. What I mean to say here, when we are increasing the demand of electricity and we are increasing the demand of transportation for some material or water as a commodity, we are generating the CO2 and it is emitted directly into the environment, causing the environmental pollution, and we are leaving the carbon footprints behind. So our basic motto and objective should be to reduce the demand of fresh water, to reduce the demand of electricity, to reduce the demand of all these transportation purposes, so that we can reduce the carbon emission, CO2 emission into the atmosphere, and we are leading one step towards the environment and sustainability. Now you can see here one image is shown, like how the CO2 emission is taking place because of the electricity generation. Various activities are maintained here, right? And were mentioned here in this particular image, and you can see how CO2 emission is taking place. Now, as I have mentioned few parameters of green construction technology, one of that I will be taking as a case study, say energy, electricity. Now, in our own college, that is NK Orchid College of Engineering and Technology, Solapur, we have installed a solar power plant on our roof terrace, right? So, I will be discussing about the plant detail as well. So, it is a fresh report. It is a report of 2nd June 2020. You can see the date is mentioned. And in the morning, I have taken this report. And today, by that time, we had generated 40.5 kilowatt electricity. And till now, since the commissioning, so commissioning has happened somewhere around 2016. Since then, we have been able to generate 151.14 megawatt of electricity by using solar panels. So we have reduced our dependability of this much amount on our conventional energy sources. So definitely that is leading to reduction in the CO2 emission. So we have reduced the CO2 avoided. It is mentioned here. So some quantity like some quantity of the CO2 emission that is avoided is mentioned here, right? So you, some net income is also calculated, that much we have saved. So it is study in last 4 years, around 40% of our electricity bill is been reduced, right? 40% of our electricity bill has been reduced. So reduction in the CO2 emission and reduction in the financial resources, using financial resource. So a step towards sustainability, we can say. This is one more slide where we can see the graph that is plotted, on daily basis. So what is the time and what is the generation of electricity that is occurring? So this type of graph we are getting daily, on daily basis, for our own generation, for our college premises. Now here the plant details are given for the same solar power plant that we have installed. So plant name you can see NK Orchid College of Engineering and Technology, Solapur. Installed capacity is 36 kilowatt. 36 kilowatt is the installed capacity. Daily we are expecting around say 180 units to produce for the electricity, and we have connected this particular plant into a central grid on a net metering system. So around 40%, around 40% of our own demand we are fulfilling by our this own plant, and 60% we are purchasing from the MSCB, or you can say electricity board. Date of commissioning is 27th April 2016, and it is installed in our college premises on the college rooftop. So CO2 avoided factor is also here, that is around 32 tons of CO2 has been avoided. We have say avoided emission of around 32 metric ton of CO2 since its commissioning. So that is, I think, a good step towards sustainability. Now this is the graph which is showing the generation of electricity in last say 5 months, since January 2020 you can see we have been able to produce around 4 megawatt electricity per month at least. So in month of April, it was bit less because of COVID issue and all. And again, in month of May, we are able to generating a little more electricity for some emergency reasons. So government has using that particular premises for some reasons, right? So after looking at the previous graphs, so it means very clearly, right? So we are avoiding the CO2 emission and all that thing. We are moving a step towards sustainability and environment, maintaining environment and sustainability. Likewise, there are a few other ways to compute the sustainability are like as follows. We can install the rainwater harvesting system, and we can reduce the demand of fresh water. We can reduce the demand of fresh water from the supply system, and in turn reducing power consumption in the supply network. If fresh water need to be supplied to different areas with higher energy, right? So there higher amount of quantity of electricity is required, which will leave behind more carbon footprint. So if we reduce that demand of fresh water to be pumped from the supply network, we are reducing the demand of electricity, and hence we are moving towards a sustainability. One more way we can adopt is reuse and recycling of treated waste. The waste that is being collected at various locations, various points in the towns, in the cities, that can be treated locally, and it can be used for the purposes like firefighting is there, landscaping is there, few more flushing is there and all. So where we are actually using fresh water. So if we reuse this treated waste, for these particular purposes, the demand of fresh water can be reduced drastically, and again we are conserving natural resources. We can also go for some critical analysis of the structure using advanced software, as I said in earlier videos as well. And we can reduce the material demand, and in turn we can reduce the material transport. We can reduce the material transport, and which will reduce the CO2 emission by means of lesser transportation. As I earlier said, if we go for economization in the material, CO2 emission can be reduced by means of transportation, which is actually occurring. Reuse and recycling of treated waste water for local purposes like firefighting, landscaping, etc., and reducing freshwater demand again. Reducing freshwater demand again. Thank you.